The fourth problem which we have in hand is a very important problem because it is a problem concerned with the Van Hoff factor. We are given that the degree of dissociation of calcium nitrate in a dilute aqueous solution having 7 grams of salt per 100 grams of water at 100 degrees Celsius is 0.7. This 0.7 is the degree of dissociation of calcium nitrate. We need to calculate the vapor pressure of the solution. Now we know that by the Raoult's law, we have relative lowering of vapor pressure is equal to the mole fraction of the solute. So the formula becomes P naught minus PS upon PS is equal to moles of solute upon moles of solvent. Where P naught is the vapor pressure of the pure solvent and PS is the vapor pressure of the solution after addition of the solute. But here an important thing to note down is, in aqueous solution, being an electrolyte, this calcium nitrate dissociates into calcium and nitrate ion. So here this formula will not be applicable. Instead, there will be a multiplication of a factor of I in the right hand side of the formula. This I is the Van Hoff factor, which is equal to the total number of particles or the total number of moles present after this dissociation of electrolyte upon the total number of moles or particles present before the dissociation of this electrolyte. So, writing this equation, if we consider the initial number of moles to be 1, 0 and 0, let's say the degree of dissociation which is given to be 0.7 to be equal to alpha. So this becomes 1 minus alpha, alpha and 2 alpha. So we can see that after the dissociation, the total number of moles are 1 minus alpha plus 2 alpha. That is the total number of moles of calcium nitrate left, calcium ions formed and nitrate ions formed. So total moles after the dissociation is equal to 1 minus alpha plus 2 alpha, which is equal to 1 plus 2 alpha. Hence we can apply the formula P naught minus PS upon PS is equal to the Van Hoff factor I is equal to final moles upon initial moles, and initial number of moles we took to be equal to 1, and hence the Van Hoff factor I is equal to 1 plus 2 alpha. So this becomes 1 plus 2 alpha into the moles of solute, which is equal to 7 upon the molecular mass of calcium nitrate, which is equal to 164, divided by the moles of solvent, which is equal to 100 by 18. This P naught is the vapor pressure of pure water, and at 100 degrees Celsius we know that the vapor pressure of pure water is 760 mm of mercury. So putting P naught to be equal to 760 and the value of alpha to be equal to 0.7, this becomes 2.4 into 7 upon 164 divided by 100 upon 18. On solving this equation, we get the final vapor pressure to be equal to 746.26 millimeter of mercury. Hence in this problem, we saw that the solute which is being added in the pure solvent is not a simple solute. It is an electrolyte which dissociates in the presence of an aqueous solution into its respective ions, and hence the simple formulas are not applicable in this problem. We replace the entire formula by multiplying the earlier thing by a factor known as Van Hoff factor. This Van Hoff factor is very important, and most of the students may commit mistakes in using this Van Hoff factor only. They don't check whether the electrolyte whether the solute which we are using in the problem is an electrolyte or not. So it is very important to check that it is an electrolyte, it is dissociating, or it is a simple monomer which is dimerizing or polymerizing, Hence, it is associating or dissociating. This thing is very important to check. In our problem, it was dissociating into ions. There may be problems where two or more molecules are associating to form a bigger molecule. In those kind of problems, we need to use the factor of Van 't Hoff's factor, which is equal to the total number of particles present after the dissociation or association divided by the total number of particles present before the association or dissociation, and our final vapor pressure of the solution is 746.26 millimeter of mercury.